Hello and welcome to this, what is going to be the first video and hopefully a long series of videos to help you as you do your study throughout the year. And in this first one, we're going to look at how to analyze a function in terms of its extrema. That is, its absolute or global maximum and minimum, and its relative or local maximum and minimum. So, if we're asked to do this type of work, regardless of the specifics of the question, the first thing that we should do is identify and label the coordinates of the endpoints and of any maxima and minima that you see here. Now, the maxima and minima are just tops of hills or bottoms of valleys. And in this case, we've got one hill towards the left and one valley towards the right. So we'll begin by identifying the two endpoints and by labeling them. So this endpoint here on the left is going to be -1, -9. Those are the coordinates. And as we're doing this by observation, we're just going to estimate correct to one decimal place. So your estimates might be a little bit different from mine. In this case, it seems to be pretty clear that it's -1.0, -9.0. So I'm not going to go any more precise than that. The endpoint on the other side is going to be 5, 9. Now, for the max and min that we talked about, that are internal points, we have to be a little bit more careful here. Let's say that we try to go for this point, the maximum here on the left, and I think the coordinates there are probably about 0.3 and -0.8. And for the minimum, which is just about here, it's maybe about 3.2 and -13.1. I think it's dipped slightly below, but if you disagree with me, that's okay. As long as we're in the same ballpark, your answers are going to be fine. Okay, so now let's talk about the maxima and minima specifically. And if we look at the absolute maximum is simply the highest point on the graph. Okay, so the highest point on this graph is 0.59, and it's a closed circle. If the highest point is an open circle, we say there is no absolute maximum. But in this point, the highest point on the graph is right here. When we are asked what the absolute maximum is, we quote its y-coordinate. So for maxima and minima, whether it's absolute or relative doesn't matter. Whether it's absolute maxima, absolute minima, relative maxima, relative minima, we give the y-coordinate as our answer. So the absolute maximum here is 9. And if you are asked where it's located, as you may be, then you can write down at x equals 5. Right now I'm more interested in you knowing that the absolute maximum is the y-coordinate. Similarly, we have the absolute minimum, which is the lowest point on the graph. And that would be this point down here. It's the lowest point on the graph. So the absolute minimum is -13.1, again a y value. And if you're required to give it, you would write down that it's located when x is 3.2. Now we also want to look at excuse me, we also want to look at relative maximum, relative minimum. So let's deal with the relative maximum first. The relative maximum is just the top of a hill. And we can see that over towards the left here, we have a little hill that I've shadowed there. So this point would be the relative maximum. So the relative max here is -0.8, and it's at x equals 0.3. And that's why we estimated what each of those points were initially, so that we wouldn't have to figure it out at the time. And then now the relative minimum is the bottom of a valley. Okay, so if we look for the bottom of a valley, this is the valley right here, and the point at the bottom of that, well, we've already picked out that point. We picked it out as the absolute minimum, but it's also, since it's at the bottom of a valley, it's also a relative minimum. Okay, so it's the lowest point on the graph, which makes it an absolute minimum, but it's at the bottom of a valley, which makes it a relative minimum. So this is going to be negative 13.1 at x equals 3.2. Okay. Now, we can do one other thing with this. We can look at intervals on which the graph is increasing and decreasing. If we talk about increasing and decreasing, then we switch to x coordinates. So let's look carefully at this. So I'm going to take a different color of pen, and I'm going to trace along the graph. This graph is increasing. As we look from left to right, it's climbing. That's what increasing means. Look from left to right, and if the graph climbs, then it's increasing. So it's increasing there, and it increases again here. Those are the intervals on which it's increasing. Okay? The way we write that is a little bit counterintuitive. We're interested in where the graph is climbing, but we actually give our answer in terms of the x coordinates. So it starts climbing at this point, where the x coordinate is negative 1. And it continues climbing until we get to this point, where the x is 0.3. And we write that as negative 1 is less than x is less than 0.3. Now, if you wish, you can use less than or equal to signs here. We tend not to use greater than, but we can use either less than or greater than. And that's because of disagreements among mathematicians over the definition of increasing and decreasing. Seem like simple words, but they have very precise definitions, and mathematicians aren't agreed on those definitions. So you have an option when you're writing about increasing or decreasing as to whether to use less than or equal. So that's one region of the graph where the graph is increasing, where the function is increasing. So we highlight that in curly brackets. And then the next one, it starts increasing again at this point. Now getting a little bit cluttered with too many colors, but the x value there is 3.2, and it increases from there all the way across to x equals 5. So 3.2 is less than or equal to x is less than or equal to 5. Okay. Now, those are two separate regions on which the graph is increasing. And we indicate that by joining them with a capital U, union, from set theory. Okay? So, this graph increases if x is between negative 1 and 0.3, and again it's increasing again if x is between 3.2 and 5. Let's look now at where the graph is decreasing. Okay? So, where the graph decreases, well, it's decreasing in this region here. Okay? It's decreasing in that region there. So, start off by writing down the x-coordinate where it begins to decrease. So this was a maximum, and this is where it begins to decrease, and the x-coordinate was 0.3. We say 0.3 is less than or equal to x, is less than or equal to, so it decreases all the way to 3.2. When x is 3.2, that's where it finishes decreasing. And that's the only interval in which this graph decreases. Okay, now there's a lot there, but if you take it slowly, and if you begin by identifying the coordinates, I think you're going to manage. Replay this as often as you need, and use it as you look through your own examples. Okay, thank you.